Okay, so we are actually getting a lot of people today.
Yeah, it's good.
Actually, yeah, it's good.
So whenever you want to start, I'll shut up and I'll just keep an eye on things.
Yeah, thank you. I really appreciate that. So it's 7:30, so I may get started slowly. Should be a little bit anyway. So hello everyone. Tonight it's just gonna be me. I'm Berta. Normally we are two people leading this introduction to the universe. It's Alistair and me. We are both members of the Royal Astronomical Society of Canada, but Alistair is on holidays today, so I'm just gonna be your leader tonight. I'm not the expert that Alistair is, so if I may not be able to answer all the questions that you have, but I will certainly try to do my best for that. And so without further ado, I'm just gonna share my screen and just gonna start with the introduction of what we do. So this is the introduction to stargazing. So like Alistair always says, this is just, we are not gonna talk about astrophysics, black holes, galaxies, or gamma rays, or anything complicated. This is just simple hobby astronomy. We plan to teach you to find your way around the sky, to talk about the moon, the sun, and all the planet cycles, and to help you achieve the Explore the Universe certificate from the RASC. So, okay, let me there. So you don't need to, so the idea is that we make all these sessions be in a circle. So if you can join at any time, you don't need to have seen any previous sessions. It's like ideally it's like you were joining us around a metaphorical campfire. In principle, we actually plan to do these sessions in the TELUS Wall of Science, but because of COVID, we are still stuck in Zoom. Hopefully in September, we can start meeting in person at the TELUS Wall of Science. And the idea is that we will have a couple of slides with some introduction about the sky, and then we will actually go out and actually look at the sky. We are going to we are going to talk about the stars, the constellation, the planets, and some features in the moon. And each session, we are going to talk about what is relevant in the sky at that time of the year, where things in the Explore the Universe certificate you can go and try to look at. So we are going to talk about the movements and cycles of the sky. This is, for example, some images of the sun setting taken by one of our members in the RASC, Luca, here from Edmonton. So for example, you can see that the sun sets farther to the east sometimes of the year and farther to the west other times of the year. And so, as I said, the original plan was to meet at the Queen Elizabeth Planetarium. That may happen in the fall. And so we will help you use your scope, and we will teach you the constellations and the stars in the sky. We will also talk about other things that are happening in the sky, like noctilucent clouds, auroras, comets, trails from planes, or all things happening. And so basically the idea is that what we want to tell you is that every night you should go out and just look at the stars, even if it's only for 5 minutes, even if it's cold, just go and remember to look at the constellations so that you can remember and have the map of the sky in your head, and then everything will come from there. Okay, so we are members of the Royal Astronomical Society of Canada. We are in this introduction to the universe. We are following the Explore the Universe certificate. It's a free document that you can download from the internet. It's free. It's basically like a scavenger hunt in the sky. Non-members can do it. You don't need to become a member to do it. And if you do it, you get a pin and a certificate. You just have to follow along, and every month we will point to you the objects that you can see this time of the year. There are constellations and bright stars. There is sections about the moon, and basically you just have to fill this log sheet with your observations, and that's all that they ask you to do for getting the certificate and the pin. There are a lot of different observing certificates in the RASC. The Explore the Universe is the one intended for new people. But there is also the moon certificate and and so Messier certificates, things that are a little bit more complicated and they do require a telescope. The good thing of Explore the Moon is that you don't need a telescope. You can just do it with binoculars from the city. You don't need to go outside to a dark sky. You don't need the biggest equipment. Just use your binoculars from the city, and then you can still have 1 year of fun and entertainment. The Royal Astronomical Society of Canada, you are more than welcome to join. It's a nice group of people. We do outreach to public and schools. We do monthly meetings. Greg presents what's up in the sky this month. We can teach you how to buy a telescope. We do have an observatory at the TELUS Wall of Science, and there is another observatory at the University of Alberta that is not part of the RASC, but it's also something that you can come and use and observe with us. We can teach you about astrophotography, and there are dark sites, Blackfoot and Black Nugget Lake, where members of the RASC normally meet to do observing at night. That provides safety in numbers, and it also provides good company to spending the night outside. The RASC also has calendars, magazines, handbooks, books, and a lot of different things that can be useful for you. And so this is the introduction for today. And now I'm gonna switch to our slides for today. And Greg, let me know if everything looks okay, please.
Looks okay, and it's Jeff.
You look, oh, Jeff, sorry, Jeff, my apologies. Yes, okay. So anyway, let me know if at some point things are not looking okay, but I assume you're looking at the, the first slide. Good. Okay. So, so we have here the outline for today. Sorry, I just apologize, but I lost my notes, so I want to keep them here in front of me. So I'm just gonna resize this. Let me know if things change. I think you're still seeing the right thing. Okay, so so we are gonna talk about the satellites and early summer sky. Then we're gonna slowly go a little bit touch some objects in the surface of the moon. Some deep sky objects. We are going to talk about double stars, and we are going to introduce a little bit the honeymoon, which is the moon, the full moon this time of the year. And then at the end, we will have a little bit of time for question and answer. Okay. There we go. There. So the international is, as usual, we begin with things that move in the sky. The brightest artificial satellite that we can see in the sky is the International Space Station. It appears to move in the sky at the same rate as a high-flying aircraft. In reality, it is about 400 kilometers up and travels around the Earth in 90 minutes. In July, we get the chance to see it 3 or 4 times in one night. So this is the passes for the ISS this month. In June, we are going to have only during the day. The passes of the International Space Station are going to be during the day, which means that we cannot see them because it has to be dark for it to be seen. But we have, for example, tonight, 25th of May at 11 o'clock, there is going to be a pass And it's going to be, so this is a magnitude, so it's going to be quite bright, and it's going to start in the west, and the highest point is going to be in the southwest, and then it will set in the southeast. The way to find all this information about the International Space Station is to go to heavensabove.com. And here you have to make sure that you put Edmonton as your location, because it normally takes, I think, the UK as a default location. So you have to change that to your town. Just you have to put Edmonton or wherever you are as your location. And then it will list all the passes for the international space in your location. And it tells you the magnitude, where it starts, where it's the highest point, and where it sets. There we go. And so, for example, tonight, just after 11 o'clock, so this is a chart of the night sky. The highest point in the sky, the zenith, will be here in the middle of the chart. And this is your horizon. If you were outside and you will have a clear view of the horizon, you will be seeing this. So the S in here means south. So if you are looking from you're looking south, this is what you will see near the horizon, and this will be the highest point. So if you're looking south, just after 11 p.m. tonight, the ISS will slide before Regulus. This is starting here, which is part of the constellation Leo. Then we'll go above Spica, here above the constellation Virgo, and finally it will disappear into Earth's shadow after 11:06. So it will be traveling the sky, the south sky, for 4 minutes, and it will be a bright object that we could be seeing. Oh, sorry. The middle of the chart is overhead, as I said, face south, and then put the S at the bottom, and that's what the sky that you are going to see above Edmonton tonight. So directly overhead lies the Big Dipper in here, just very close to the zenith, with the handle arcing to Arcturus. So the way you take the Big Dipper, that most of the people know, you can follow the tail and arc to Arcturus, which is the second brightest star in the sky. So it's not hard to miss it. It's hard to miss. It's very easy to see. Sorry again. And then you can imaginary spike to Spica. So you arc to Arcturus and you spike or jump to Spica, which is another bright star, and it's very low in the horizon for us here. And so that's normally how you know your way around the sky in summer is take the Big Dipper, go to Arcturus, and then go to Spica. This is one way to help us remember the names of the stars. In the nights to come, step outside and repeat arc to Arcturus and spike to Spica. And by next year, the name will be familiar. You will remember them the rest of your life. So these kind of little tricks can help you find your way out. Now, you are outside again, and instead of looking south, you look east. So you have to take your sky chart and turn it 90 degrees. Before we were looking at it from this point of view. Now, because you're looking east, you have to have this part in front of you. And this will be your horizon. And this will be the stars near horizon looking east. And this will be the highest point in the sky. If you look up, the Illuminati Vega sparkles bright white. This star in here, it's a really beautiful bright star, and it's kind of blue-white. By eye, it's easy. It's not so easy to see the colors of the stars, but for example, if you compare it to Arcturus, Vega will certainly look a little bit more bluish because Arcturus is a little bit more orange. So you can check them out like that. It is the brightest star in the constellation Lyra, the Harp. To the left is the brightest star, the Neb, here, of Cygnus the Swan, which we will see for the next 5 months. So these constellations are going to be up in this Vega, the Neb, and are going to be up in the Altair. This is the summer triangle. Now it can be seen in the east, but as the summer continues, we are going to see them higher up, and then you will see them up in the south sky, and that will make the summer triangle. These are the very easy stars to find in the summer. And so we are going to highlight a constellation. We always try to highlight a constellation in this presentation. This month, we are going to talk about Draco, which is a constellation not so well known because it's actually not very bright. But nevertheless, it's still a beautiful constellation. Above Vega lies a pair of stars that mark the head of Draco. So Draco is this line in here. Okay, it's a dragon in the mythology, and it's more like a snake with a head. This will be the head, and these stars follow Draco. As you can see, they are very faint, but they are sandwiched between the Big Dipper in here. Okay, this will be the sky looking east in this time of the year. This is the Big Dipper, and this is the Little Dipper, where you have Polaris and the two stars. The Big Dipper can be seen from the city. The Little Dipper, you can only see Polaris, which is the tail of the handle, and the two bright stars that are the ones that make the cap of the Little Dipper. And so these two, and Polaris, are the ones that can be seen from the city. The other ones are too faint to be seen. And so between the Big Dipper and the Little Dipper, you can see this constellation in here that is Draco. Look a little closer to see two more stars that all together make a square box. So if you start with if you start with Vega and you go up, you will see these two bright stars. And then if you look a little bit closer, you will see the other two. And those make a squarish box that is the head of Draco. Draco is a filler group. The other is a filler group because it's just a constellation that basically takes the space that is left between the other constellations. The other groups are well defined, and the leftover becomes a long, sinuous strings of fainter stars. It wasn't until Alistair's third year of astronomy did he really bring the curving chains of the stars into one group. It's best seen at medium sky, not truly dark, but dark enough. Okay, so Alistair is pointing out that it took him 3 years to do in astronomy until he actually found this constellation and was able to make it up. If you go into a truly dark sky, there will be so many stars around that it will be difficult to make it up. But if you are in the city, the stars are not bright enough, so you will not see it at all. So he says that the best place to see Draco is actually a medium dark sky, so that you can still make up these stars, but but there's not so full of stars that you don't know which one is which. Okay, if at any moment anyone has a question, please let me know, but if not, we just keep them for the end. Okay, and so the astronomer from the Renaissance, John Bayer, painted Draco like most of us will describe a Chinese dragon, closer to a snake. So again, this is the Big Dipper, this is the Little Dipper, and this is the chain of stars that we've been talking about with the head of the dragon. And so those are the stars that make Draco here. That's how it was painted. The star Tuvan is important because 5,000 years ago, it was the pole star. So our pole star right now is Polaris, which is where we point north. But 5,000 years ago, this was the North Star because the axis of the Earth is spinning. And so when it spins, it changes the star at which it's pointing at. And so it's not always Polaris. So 5,000 years ago, it was Tuvan, and to which the Egyptians, so some people suggest that the Egyptians pointed the pyramids to Tuvan because that was the star, the pole star at the time of the Egyptian. Is not something that is proven. It's not a scientific fact. And it's just a concept. But basically, maybe what you should keep in mind is that around the time of the Egyptians, the pole star was not Polaris, but Tuvan. The circle drawn, okay. Oops. Sorry. Oh, sorry. I want to go back, and it's just going forward. My apologies. There. Okay. So there we go. There we go. The circle drawn in here traces the path of Earth's pole around its 26,000 circle of what astronomers call precession. And in about 13,000 years, Vega will be our pole star. Remember, so this is the constellation Draco. Keep this star in mind, New Draconis, because we are going to come back to it later as when we talk about double stars, okay? So now we are going to move to the moon section. Again, Explore the Universe certificate have a section about constellations and stars, which is what we just talked about. Then the next section in the Explore the Universe that you are asked to do is to look at the moon. So, you know what, I'm just, so here in this slide, I talk about the Mare Nectaris, one of the sea basins that you can see in the moon. These things you can actually see them with binoculars, so you don't need a telescope. Obviously, a telescope will always show you a better view, but you can actually see these features and identify them. These are the different mare. And so today we're going to talk about Mare Nectaris. This basin is around 350 kilometers in its widest point. And it's an impact crater that formed around 3.9 billion years ago. Lava flowed into it and filled it. The smallest of the circular maria is still covers 10 degrees of the lunar surface. There we go. And then after this mare, we are going to talk about a moon crater that you are encouraged to look at. And this month, we are going to feature Posidonius. Sorry, I apologize for that. This crater here in the sky, in the moon, I apologize. It is located on the shore of Mare Serenatis, which is this one in here. And it has crater walls that go up to 2,300 meters high. So it's actually pretty high. You can see the shadow in here tell us that it's actually pretty high. It's 95 kilometers wide, and it has very irregular terrain inside. And the best view of this crater is when the moon is around 5 days old. And we measure the age of the moon starting from when we have new moon. So new moon will be day 0. And then as the moon progresses in its 28-day cycle, we call the day after new moon day 1, the day after that day 2, until we reach day 28, right? So Posidonius can be seen best. So the best time to observe a crater is when the terminator, which is this line in here, is near to it. As you can see, for example, these craters are very well defined because you can see the lights and the shadows very well. When a crater is away from the terminator, it becomes completely washed out and you cannot make it out so clearly. So the best time to see Posidonius is when the moon is about 4 days old. And this month, that's going to be around the 4th of June. So if you go out and you can look at the moon in the 4th of June, that will be early in the afternoon because it's early moon. You can look in the sky and you will see, you can find Posidonius with your binoculars. This is an image of Posidonius taken by the Lunar Reconnaissance Orbiter. And so you can see that it's a big crater with craters and rugged terrain inside and very tall walls that have deep shadows. Oops. Okay. So now the next section in the Explore the Universe, it's actually to look at planets. But this month, most of the planets are up just before sunrise. and so it's not the best time to actually look at them. So in the fall, we will have Jupiter and Saturn up in the sky at night. So then it will be much easier to see them. So then we will start featuring the planets again. But now we just jump into the next section of the Explorer Universe, which is the deep sky objects. Now, deep sky objects is a term that basically contains a lot of different objects, again, that we can see in the sky, such as open clusters, globular clusters, emission or reflection nebula, planetary nebula or supernova remnants, or galaxies. Okay, so all these objects that look different than a star in the sky is what we group into deep sky objects umbrella. And so today we are going to feature M13, which is a beautiful globular cluster in the constellation Hercules. It's very easy to see it in the summer, and it's because it's located, because it's easy to find Hercules because you can find these 4 stars. It's close to Lyra, the one that we talked about before. This is Vega. We talked about it. It was in the east, right? So this is Hercules. You can find these 4 stars. It's called the keychain asterism. And between these 2 bright stars, if you take your binoculars and just basically scan between them, you will find this fuzzy patch in between. That doesn't look like a star, it's more like a fuzzy patch. This well-known globular cluster contains hundreds of thousands of stars. So that's a fuzzy patch again, I'm sorry. Contains thousands of stars. It's a globular cluster Hercules, from the Hercules constellation. So you have to look for a fuzzy star south of Eta, the northwest keystone star. It's node, it has magnitude 7 stars on both sides. So if you look at it with binoculars, you may note that it has 2 bright stars on each side. It's around 22,180 light years away. And globular clusters are tightly bonded together by gravity and contain very old, mostly red stars. So M13 is one of the brightest in the sky. And so certainly it's one of the jewels on the summer sky. And I certainly encourage you to try to go and look for it. These are different pictures taken of M13 by different members of the Edmonton RASC Society. Tom Owen took this picture. Murray Paulson took this one. Abdur Award took this one. And we even have amazing sketchers. So this is not a picture, this is actually a sketch done at the telescope by Eric Classus from Calgary. So these are different views of the same object. That's if you look at it with binoculars, you don't make out the stars that make the globular cluster. You will just see a fuzzy patch in the sky. But this is how it looks through a telescope, and this is a sketch. So this is how it will look to your eyes. And now a different globular cluster that we can also talk about today. So this is Hercules that we were mentioned before. And so beside it, there is another constellation called Serpent's Caput, which is a little bit fainter and not so easy to make out. But Corona Borealis is a constellation that you can see very clearly in the sky. And so then you could find another globular cluster called M5. And this one is as bright, as big and bright as the M13, the one that we have mentioned before. It's just maybe a little bit more difficult to find because it's an area of the sky with less stars. It is located about 2.5 binocular fields north of Beta Librae, north of this star. So if you find the constellation Libra, if you move up from here, then you can actually find M5. Maybe that's the best and the easiest way to find it is going up from here. It's around 24,460 light years away. And this globular cluster is about 13 billion years old, one of the oldest globulars in the Milky Way. And again, we have some photographs of this other cluster, M5, by members of the RASC from Edmonton or Calgary. The first picture is by Tom, second by Murray, and again, sorry, this is a sketch done by Eric Klaus from Calgary. And then finally, the last section of the Explore the Universe talks about double stars. So it encourages you to go out in the sky and look for double stars. They're really, sometimes they can be really pretty because they're just two stars together. And sometimes they have contrasting colors or contrasting magnitudes that make them very, very fun and interesting to look at. So today we are featuring Alpha Librae. So this is starting here from the constellation. So you have to find the constellation Libra, which is low in the southern sky. So it would be close to the horizon here in Edmonton. The horizon is more or less around here for us. And if you find Libra, you can find this star in here. And this star is actually a double star. It's made of two stars. They are very close to each other, Alpha 1 and Alpha 2. It's a physical binary, which means that they're actually linked together. These two stars are actually, you can have optical binaries, which means that they are stars that are actually not related to each other, but you can see them very close because they just happen to be aligned that way in the sky. Or you can have physical binaries where there are actually two stars that are gravitationally bonded to each other, and they'll orbit each other. And so this one is, there are two stars that are actually bonded to it, they are gravitationally linked to each other, and they have contrasting colors. So when you look at them with your binoculars, you can actually see that they have different colors. It's about 77 light years away. And these stars form a physical system as they move together. And just an interesting note that these stars are both themselves binaries, but you will not be able to see that with your binoculars. So in total, we actually have a system of 4 stars, but you can only see 2 of them with your binos. Again, there we go. And then the last double star that we are going to talk about is something that we mentioned before. Again, we have the Draco Constellation. This is the Big Dipper, and this is the Little Dipper. So this image is turned from what we were seeing before. So if we look east, we will be looking, or kind of northeast, we will be looking from this side. This is Draco, and this is the head of the dragon, and this is new Draco. It's an standing even magnitude double. It's around 100 light years away, and this star is named Kuma, and it's one of the most easily seen double stars in the sky, in the northern sky. So just, it's again another motivation to try to go and look for Draco, to just also search for this double star in here, which you can very easily see with your binoculars. And its name is Kuma, the star. Okay, so now we are moving to, we've finished talking about the different objects that you can see in the sky at this time of the year and that are listed in the Explore the Universe certificate. We always, Alistair and I, make a little, a little note about different events that are happening in the sky at this time of the year. And Alistair wanted to highlight that the full moon in the month of June is called the honeymoon. And he wanted to explain why is that. He says, yes, many newly married couples take their honeymoon in June and July. And it's not a coincidence that the full moon in June is called the honeymoon, because its color is exactly that, it's golden honey. The lower in the sky an object is, the more atmosphere the light travels through, and the more blue light is scattered away, leaving progressively yellower, then orange, then the redder colors. So if you see the moon, the full moon in June, it won't be a white, bright moon. it will be actually a kind of more honey color moon. Oops, again, sorry. And the reason for that is these diagrams are all to scale, which is something that you don't often see. And so the green disk is the Earth. So you have to think this is the surface of the Earth, and you are here. Okay, this is the surface of the Earth. The blue line is near the top of the atmosphere, which is more or less 81 kilometers height. So again, this green line is the surface of the Earth, and this is 81 kilometers height, which is more or less the height of the atmosphere above us. So in all these images, we just have the Earth and the atmosphere. And so when you are looking up at an object that will be up in the sky there, this is how much the light is traveling through the atmosphere. And the black line is the horizon. When you look directly up, the space is barely 80 kilometers away. And as you look lower down, so if the objects are lower, so if we are looking, that would be our horizon. So when you look something up, the light has to travel 81 kilometers of atmosphere. But as you start looking at objects that are closer to the horizon, like in here or in here, the light that is coming from those objects to you, you are here, and you are looking at these objects as they are getting closer and closer to the horizon. The light, for example, where something is, as you look lower down, the paths closer to the horizon become longer and longer. And at 10 degrees above the horizon, you are looking through almost 400 kilometers of air. So the light that comes from this object will have to travel all this distance to reach to you, which is almost 400 kilometers instead of the 181 kilometers that we saw, 85 kilometers that we saw here. 5 times more than looking straight up. This is why objects in a telescope pointed low are more blurry. There is 4 times more blur to look through. So as Alistair was pointing out, the more an object travels to the atmosphere, the more the blue light is scattered, and then it disappears, and so it looks a little bit more yellowish. And so that's the reason why the full moon in June, which is going to be very low in the horizon, is going to look more yellowish, and it's called the honeymoon. These are images. A summer moon stays low in the sky for its whole path. So if you can see, the full moon in June is kind of very low. These are images that Alistair took from the, from the early in the morning. Early at night when the moon appears, the full moon appears, until early in the morning when the full moon sets. So the full moon traveling all around the sky in one night is photographed here by Alistair. This is a panorama that this is Alistair, and the second is Luca, shot from the top of the parking lot of the Royal Alec Hospital. So they were at the Royal Alec Hospital. I guess this is looking downtown from there. And you can see how the moon stays very low in the sky for the whole night. As a reminder and comparison, here are the paths of the ecliptic. Ecliptic is the line where the moon and the planets are. They don't go very far away from the ecliptic. Is the plane where the Earth and the rest of the planets and the moon are all rotating. In winter, the pale blue line, this is the ecliptic. This is the ecliptic in here. And so in the summer, in the winter, the ecliptic is really high. So this will be the sky in winter, looking south. We have here Orion, which is the constellation that everyone knows in winter. So the ecliptic is actually very high compared to the horizon. Okay, so that's where we see the moon and the planets and the sun. But in the summer, again, this is the Earth and this is the ecliptic, and this is the stars that we see in the summer looking south. The ecliptic is very low to the horizon, and that's why in winter it rides high. and in summer it goes low. The sun is opposite the full moon. So in summer, the sun goes high, but in winter it keeps low. So the moon is closer to the ecliptic, and so the sun is actually the opposite. That's why in summer the sun is really high in the sky, and in winter is lower. And so the moon does the opposite, the full moon in summer does the opposite. And okay, this is the end of the presentation. Please let me know if you have any questions, and I hope I made things understandable by everyone. If you can, please switch on your micro and ask the questions, or if you feel more comfortable, you can always write them in the chat. I'm also monitoring the chat, so please do so. Again, the real expert here in astronomy is Alistair, so if anything that you ask, I will try to answer, but Alistair is not here today, so I may not have the answer for you, but just ask anyway. Also, let us know if there is anything else that you would like to talk about in the future. As we say, we kind of center in the Explore the Universe certificate, and we basically highlight the objects in there. But if there is anything else about astronomy that you're interested at, please let us know, and we will try to address it. I'm a homeschool mom. I have a question in the chat. It says, I am a homeschool mom. Do you have any suggestion for stargazing with young kids? Late nights in summer, cold weather, and other seasons. So I'm a mom of two. I'm not a homeschooling mom. My kids go to school, but nevertheless, I've tried. I tried to get them interested in astronomy per se. I can tell you from my experience that my kids were never, I don't know how old your kids are. Little kids cannot actually see very well through a telescope. So when you try to 7 and 8, they are borderline. I will actually, personally, in my personal opinion, also as a mom, and with my experience at the observatory, the kids like two things, in my opinion. They like to learn about the stars and the constellations, so I would not bother with a telescope. Telescopes can be finicky. You have to learn how to use them, and then the kids move them, and then you have to find the object again, and then they look at it and they don't understand what they see. And I just wouldn't bother, just maybe with binoculars, but not even. I would suggest two things. Print out Google Explore the Universe certificate and print out the section with the with the constellations. It's divided in seasons, so you have the spring, the summer, the fall, and it just lists some constellations to find. And then, just print out a star chart and just play the game of let's find the constellations. And so just go out and say, okay, guys, can you tell me where the Big Dipper is? Maybe learn them before at home, study the shapes of the constellations, and then go out and point more or less in the area of the sky where the constellation is, and let them find it. At least my kids personally don't like that I tell everything. They want to discover it themselves. So it's more fun for them to just play the game of just go and look at the constellation in the skies. Once we've and so that's one thing. And another thing, at least my kids, they like to learn about astronomy, about black holes and things like that. So for that, maybe you can find some books, or there are a lot of there is, for example, a resource called Discover the Universe, I think it's called, for homeschooling. For the schools and homeschooling is a resource. It's called Discover the Universe, and it's part of, I don't know who, it's a Canadian resource. And they have a lot of lessons and things like that about the sky. So I hope that answers your question, Megan, about kids and the sky. Also, NASA, in conjunction with the Astronomical League, had a program. Let me just, I got it for my kids. They never really were very much interested. It's called, You can request it. It's free. It's called Sky Puppies. It's part of, it's an observing manual. It's part of NASA and the Astronomical League in the US. If you email them, they send this thing for free. And it's intended for kids to learn about the sky. And it has a little bit of introduction and then a little bit of questions to answer. So you can Google it, Sky Puppies. And I think it's up to 10-year-old kids. So it will be perfect for your kids. Okay. So Caroline asked, once we fill out the Explore the Universe and a star chart, then we can obtain an observation certificate for the RASC? Yes, of course you can. So you can obtain it from two ways. Either you can, it's written on the Explore the Universe webpage. So you just have to, it can take up to 9 months to a year to do the Explore the Universe because you have to follow the sky through all the seasons. So you cannot do it in a month, even if you do all your effort, because some of the constellations and some of the objects are only there in summer or in winter. So you have to follow it through the year. And then you can send a copy of your log webpage, your log page to, there is an email given in the Explore the Universe page and from the RASC. So you can send it to them and then they will send you the pin and the certificate. And or they can, you can send it to Bruce McCurdy, I think is the our RASC member here in Edmonton who is in charge, and he will review it and send it. Again, everything is explained in the webpage from the Explore the Universe certificate, what to do when you have filled it up, but you basically have to send a copy, a scanned copy of your log page to them. I'm a new member with the RASC out of Ontario. Okay, so again, in the Explore the Universe webpage, they have for every province of Canada, who do you have to contact to get your pin and certificate. Your 8-year-old wants to know whether Orion is around in the summer. No, Orion is, the best time to see Orion up in the sky is January, February. That's when you see it at night around 5 or 6 o'clock in the kids' time. You can, in the summer or in the fall, it starts being up very early in the morning, but you don't want to be at that time outside. So the best time to see Orion in a kid's time at night is to go January and February. And Jeff asked me to hold the Sky Puppies again. This is the, I guess, I don't know, of course it says Sky Puppies Observing Manual. And it's from the Astronomical League and NASA. So if you Google Sky Puppies and Astronomical League, I think you can find it. Maybe if someone finds it and can put the link. I don't want to start searching for it, but it's basically a little manual that has a little bit of my mythology, some questions, some themes for the kids to fill out. And you can, and I think they intended for homeschooling and Girl Scouts and Boy Scouts and, you know, these kind of organizations. It's intended, and it has sections about the stories in the sky. So it explains the Big Dipper constellation with different mythologies and things like that. And they send it to you for, you mail them and they send it to you for free. Okay, I think I've answered all the questions. Any other? But anyway, Megan, if you find something that looks for your kids, let me know, because I never get to my kids. You know, when I get my telescope out, they run away. Maybe I'm a funny mom, but they just don't want to see my things. Anyway, any other question? Thank you to everyone for saying. We have a few good evenings, but we never last more than a few minutes. Yeah, that's the thing with kids, you know, they have their attention span. And so for me, instead of lecturing them about the sky, which they hate and they run away, the best thing is to let them discover things and just try out. And maybe even make their own constellations. That's another game that you can play. Say, okay, this is the constellations that are there, but just imagine your own and make a story about it, or things like that. Okay. Any other question?
I'll just say one thing, Berta.
Yes.
Because I had all girls, and they were all in guides, and guides have a pretty good, brownies and guides have a badge program for stargazing, and it's pretty good. It's very simple, and but they, learn how to find directions and learn the major constellations. And I've taken my telescope out and had them look at a few things. 7 and 8 can look at a telescope as long as it's something really cool like the moon or Saturn. It would be kind of a waste to show them a globular cluster. They're just going to go, that type of thing. But the moon and Saturn are always a good favorite, are always a favorite for young kids. But 7 and 8 is a good age for that. If you're like, at the observatory, people bring their 2, 3, and 4-year-olds and stick them up to the telescope, and it's just kind of, whatever. They're not seeing anything. They'll see whatever their parents tell them to see. So whether they see it or not, I see them with both eyes closed, and yes, I can see it. Okay, good.
I totally agree. Planets, that's what I wanted to say when I said 2 things, kids, constellations. And if you're going to have a telescope, just again, like my experience in the observatory too, is that they only really like planets, and basically Saturn because it has the rings.
Yeah. And Cubs and Scouts also have a badge program too, so for boys.
Okay. If anyone has any other experience with kids, we are more than welcome to hear about it. Anyway. Okay. So other than that, I think we will still have a meeting at the end of June. Alistair will be back, I hope, by then. And then we will highlight things that are in the Explore the Universe certificate that you can see in June. Yeah. And so if there are no more questions, I think the session here is over. And I hope you all got what you wanted, that you came here tonight. And I hope to see you next month in June, all of you.
Okay.
All right.
Thanks, Berta.
Bye. Bye, everyone. Bye.